All right, y'all, we have day 2 now, so let's get this show on the road. So 360 degree theorem, that just means that the interior of the circle, okay, adds up to 360 degrees, okay? So all these angles inside add up to 360. A central angle is a central angle goes from the center of the circle. All right, so the central angle is an angle where the vertex is the center of the circle, okay? So the central angle. So I paused just to write it all down. I know some of you like to skip ahead and pause and then write things down. So thank you for those who are listening. Hopefully you find it beneficial. So central angle, again, the vertex is the center. It goes central angle, okay? So that will be different than some of these angles that you'll see that go from the side to side. That is not a central angle because it doesn't go through the center, okay? So central angle is very specific. Okay, an arc is 2 points on the circle and it's the broken parts in between. So that says in between it. Okay, so the arc is part of the circumference of the circle. It's the distance of just this chunk. And a minor arc, think about what minor means. Minor means a minor arc is an arc that's less than 180 degrees, okay? And what do you think a major arc is, y'all? Well, then it must be an arc that is more than 180 degrees, okay? So if you notice, this major arc, wowza, is more than 100 degrees compared to the minor arc, which is this little thing. So think of a Pac-Man. So think of this as the mouth of the Pac-Man. This is his mouth, and then this is his body, if you're trying to think of it that way, okay? Arc is on the circle. Angles are inside for this central angle. All right, now what on earth is a semicircle? Well, semicircle is right there. Okay, that just means the endpoints are the diameter. The endpoints of the semicircle, okay, are the diameter. So it's going to equal 180 degrees. Okay, so sorry, let me go back to some verbiage. Okay, so if something is a circle, so you could call this circle C. Okay, that's the code. All right. When you see angle, let's say you say angle C, you have that little sign in front. An arc has this little loop. So AB, you're going to make a loop like this, okay? And then if you wanted to make the major arc, major, B to A, okay? Oh yeah, you want to include the D so then you know it's the major one. So B, D, A, and then that's the major arc, and it has that little hoop over it, so then you know it's an arc, okay? So make sure you have that circle C, angle C, minor arc AB, and then BDA. If I wrote AB for the major arc, again, I would just think it's this section, not the whole thing around. All right, now let's go to semicircle. So if I wanted to say semicircle, I could say BCA, right? So BCA would be a semicircle. Okay? All right, so the central angle theorem, I kind of explained it right here so you wouldn't have to write it. The angle measure of the central angle is congruent to the measure of the intercepted arc. Intercepted is the part right here that goes with the central angle, okay? So this and this are the exact same, okay? So think of it. An angle opening up that big is going to have the same measurement as the arc, okay? All right, so when reading an arc and finding the measurements of the arcs, you should always use the shortest path, okay? So I wouldn't want to go all the way around for this thing. I want to use this section if I wanted to find that. I'm going to take the shortest path to find it. Okay, so when it says something about an indicated measure, that's what we're trying to find. We're trying to find the measurement, okay? So this central angle is 70, so the shortest path of MN is this section right here. So if that is 70, therefore this is 70. So 70 degrees, and it's that simple. All right, now let's think about a little bit trickier of one. So N to Q. All right, guys, well, let's think about this. If MQ is a diameter, if this thing is a diameter, this whole thing is 180 degrees. Okay? So is all of these together. And if this is 30, this is also 30. Okay, let's move this up. All right, so now I need to find out what this little section is. Okay, so then I can add those two together. So I have 70 degrees plus 30 degrees plus, I don't know what this is, right? This angle. So let's just make it M, and that equals 180 degrees. So this is very similar to when we're trying to find triangles, because triangles also add up to 180. What? Crazy. So I have 180 minus 70 minus 30, and that's 80 degrees. So M is 80, okay? So this is 80, therefore this is 80. So if I'm trying to find arc NQ, N to Q, I'm going to add these two together. So 80 plus 30, what is that? And that is 110. 110 degrees. Bada bing. All right. So now that I made this all crazy, now let's look at the next one. Okay, again, I like to add color so I know what I'm talking about. So NQR. So NQR. So I want to find that whole thing. And it told me that NR is the diameter. Well, if that's the diameter, this is a semicircle. So NQR is 180 degrees. Now, if I went this way, that's NMR. Okay, so that's a little different than NQR. So please be careful on the inside. Okay, so that's a semicircle. Okay, all right, so let's do MRQ or MRP. MRP, so MR to P. There we go. All right, well, let's think about this. If MQ is the diameter, therefore this whole thing is 180 degrees, and therefore this whole thing is 180 degrees. So the arc is the same as the angle inside if it goes through the circle, if it goes through the center. Okay, center, center. So now I have 180 plus this little 30 right here, because this is 30, therefore this is 30. The intercepted arc goes with the central angle. So now I'm going to do 180 plus 30. So what I would do if I had notes is I would write down the information on how on earth I got these answers. So then it's not just these random answers and I don't know what I'm doing with them. Okay, so showing that work will definitely benefit you. So this was finding the degree as the indicated measure. All right, let's move it right along. Q to R. Okay, I want you guys to think about this one. So how on earth do I find this one? Okay, well, this whole thing is 180 degrees, right? Okay, so we know that. I know that, so if that's 30, what would be these two angles, right? I could think of it that way. Just talking it out. Woo! Well, I also figured out if that's 30, I figured out from these angles. Didn't I find these angles out too, guys? So N to Q was 110 because I found out that this was 80, right? Yes. So I found out that this was 80 degrees. So I'm using what I know already. Okay? So if those are that, then I can add these three together because NR was, again, 180 degrees. So if this is 80 and this is 30, I can find out what this angle is. So 80 plus 30, subtract that from 180, and that is 70. So 80 plus 30 plus, what is that measure? Equals 180. So N equals 70. So that's that measure. So I kind of just make up different angle, different variable numbers so then I know what I'm looking at. Something also to think about, this looks familiar about these angles. These are called vertical angles. Vertical angles are congruent. And if you notice, this and this are congruent. Therefore, this is also 70 degrees. So that's another way to think about it. Okay, the very last one is MR. Okay. Well, if you think about it, again, this is diameter, and that's 180. So this whole thing together is 180. So what's 180 minus 70? Well, that would be 110. Therefore, this is 110. So 110 degrees for the MR. Okay, for that arc. Again, central angle. The central angle is congruent to this one out here. All right. Now let's think about distance. So if I wanted to find an actual distance, so if I was running around the circular track and I was trying to figure this out, so this circular track, and I wanted to find just this section of it, right? Okay, how would I figure that out? So there's this equation right here. So 2 pi r is the circumference of a circle. Okay. And this central angle over 360, that is just the section of the circle that I want, okay? So I just want a section of the circumference. I don't want the whole thing. So that's how I find the length or the distance of something, is by using this equation. So making sure that you understand what that means. So UR, okay? So if you notice, this symbol means 90 degrees, so therefore this is 90 degrees. So now let's find the length. All right, so I have 2 pi r, okay, times, I have 90 over 360. And the rule about radius or radii is if this is 4 feet, this is also 4 feet, right? The radius is always the same. So I'm going to plug in 4 in for the radius. Now here's a little trick. You can cross out the zeros, and then I have 8 pi times 9 over 36, and then I can multiply that together, okay? So I'm just going to put it over 1 and multiply 8 times 9, which is 72. 72 pi over 36, and let's reduce that. So 72 pi divided by 36 is 2 pi, all right? So that is the length of just this section, is 2 times pi, which would be 3.14. I want to put it in terms of pi, because then that will be a little bit easier for ourselves with some of these calculations. All right, let's try number 8, and then I'm going to have you work out some of these on your own and see what you get. All right, so RS. So if this is 60 degrees, guys, that means this is also 60 degrees. So let's set it up. So 2 pi, the 4 is going to be used again because the radius is the same in that circle. Then I have 60 over 360. Again, if you notice, I can cross out those zeros, make it a little bit easier. I have 8 pi times 6 over 36, and then I multiply 8 times 6 together, which would be 48 pi. And I just bring the pi on for the ride over 36. And now let's see if I can reduce this. So 48 over 36. So I can reduce that to 4 over 3 pi. Okay, so that is that one, 4 over 3 pi. There we go, setting them up and solving. All right, now let's try 9 and 10. I'll set it up and then you solve, and then 11 and 12 we'll kind of talk it out too. All right, so let's remind ourselves, so 2 pi r times the central angle over 360, because again, all circles add up to 360. All right, STU. So it's really important that I use the whole thing, STU. All right, so if this is, we got to figure out, okay, if this is the diameter, right? This is 90 degrees also. And then I need to figure out what this one is, okay? So this is also 180 degrees together. So if that's 60, this has to be 120 degrees because those two have to add up to 180. These two also have to add up to 180, okay? So now if I want to go from STU, I have 120, so 120 degrees, and I also have 90. So I have to add those together, and that would be 210. Okay? So I have 210 over 360 times my 2 pi times 4, and then I can change that to 8 pi. I can cancel out the zeros, and I have 21 over 36. I can keep reducing if I want to, or I can reduce at the end. So then I have 8 times 21, and that's 168 pi over 36. Holy cow. So let's see if I can reduce that and get a more simple fraction. So that's 14/3. So 14/3 pi would be my answer. All right, now let's think about RT. So RT, so I'm going to highlight that one to kind of show you what I'm looking at. And if you want to, you guys can always feel free to like redraw the circles if you want to just see one section. So RT, it's a semicircle, so that automatically means it's 180. Okay, so 180 over 360. I can reduce that, and then I am timesing that by 8 pi, because again, this front part isn't changing. The circumference of the entire circle is not changing. Now, 18 divided by 36 is 1/2. It's half of a circle. So I can just reduce it like that if you want to before you multiply. 8 pi times 1 is 8 pi over 2, which just becomes 4 pi. Okay, and does that make sense? If the entire circle's 8 pi, and I want half of that, well, that would be 4 pi. Okay? All right, URS, I'm going to kind of set it up for you. So 90 plus 60. Okay? Again, I'm kind of drawing, kind of erasing so you can see what I'm talking about. So it says URS. URS. Okay, so that's 90 degrees plus 60. So that's 150. So I have 8 pi times 150 over 360. You can cross that out and reduce it. If you want to reduce ahead of time, feel free to. It has to be for both. So I'm going to, let's divide by 3. I can divide 3 on top and bottom. So then I have 5 over 12. Okay, and then I can multiply across. Again, the 8 pi goes on top. So 8 times 5 is 40 pi over 12. Okay, so the first number, you're going to put a 1 in the denominator, okay, and then multiply across. And then from here, I can reduce by taking a 2 out of top and bottom. So I have 20 pi over 6. Oh, I can go even further. Let's take out a 4. Go a little bit faster here. So 10 pi over 3. Okay? All right, so ST is your last one. So S to T, I think we already figured that one out, right? Did we figure out what that angle was worth? If this was 90 and this was 120, so if this angle inside is 120, for all of those to add up to 360, or for these two to add up to 180, therefore ST has to be 120 also. So how would you set that up? 8 pi times what over 360, and multiply across and solve for number 12. All right, so now we try your homework out. Day 2, remember what is a measure, okay? So think about what a measure is, okay, compared to what a length is. If you're talking length, you're doing 2 pi r times the central angle over 360. And if we're just talking about the measure, if this is the central angle, that is the same as the intercepted arc. It's the arc that, think of the arc that's attached to that angle, okay? So try these out. Remember, all circles add up to 360 degrees, and try that out. All right, thanks, guys. Have a great day.